Hello everyone, my name is Aditya Tiwari, Assistant Professor CSV2 Bhilai. In this tutorial, we discuss about Radix sort algorithm and sorting application. So, sorting is a technique to rearrange your data either in ascending order or in descending order. So, there are a lot of sorting technique by which we can sort our data either in ascending way or either in descending way. So, Radix sort is one of the approach to rearrange your data in that particular order. So, Radix sort algorithm comparison by creating and categorizing elements based on their radix. For elements with more than one significant digits, it repeats. M is a non-comparative sorting algorithm in computer science. It avoids the bucketing process for each digit while reversing the previous steps ordering until all digits have been considered. Radix sort and bucket sort are almost equivalent. Bucket sort goes from MSD to LSD, while Radix sort is capable of both direction in LSD also, in MSD also. Here you can take a look at bucket sort algorithm with time complexity also and pseudocode and also the application of this Radix sort. First, we understand the concept of Radix sort, why we required and what is the main purpose of Radix sort algorithm. So, Radix sort is a linear sorting algorithm. Radix sorts time complexity of O of ND, where n is the size of the array and d is the number of digits in the largest number. Suppose we having a values like 999. So, here we having a 3 digits, the maximum place digits is 100 place, ones, tens, 100 like that. So, D is indicating the largest number, the largest position number where the largest value will be holding in which tens format. So, it is not an in place sorting algorithm because it requires extra space. Radix sort is a stable sort because it maintains the relative order of elements with equal values. Radix sort algorithm may be slower than other sorting algorithms such as merge sort and quick sort if the operations are inefficient. This operation includes sub, insert, list and delete functions and the process of isolating the desired digits. Because it is based on digits or letters, Radix sort is less flexible than other sorting techniques. If the type of data changes, the Radix sort must be rewritten. By this example, we can understand the concept of the Radix sort logic. Suppose we having a values in a lot of format. So, in the first table we having a lots of value like 132, 543, 783, 63, 7, 898 and 49. So, first you fill these, put the 0 marks in the prefix of there where the number is like 7, we have to prefix the two zeros. So, because of our highest digit number in that particular table is 898, that is why we can say the maximum position value is comes under the 100 place, that is why we fill the prefix value 0 where the digits are values are like 7 or 49, we have to prefix the 0 value. Now, in a first table you have to concentrate only the ones place values, like here we are having a numbers in a 3 digits. So, first is a ones place, second is a tens place and third is a 100 place. So, don't go for the tens or 100 place, first you have to focus on the ones place value. So, here we are having a ones place values like 2, 3, 3, 3, 7, 8, 9. In that way, you have to rearrange your data as per the ones digit number. Suppose the number are given in this format. So, you have to take a smallest value at the upper end as compared to the lower, the bigger value as the lower end. So, you have to 2 should be the first value, arrange your data and 2 should be the holding the top position. Then the next increment, next bigger value like 3, next is 7, next is 8, next is 9. In that way, you have to rearrange your data as per the ones place. Don't go for the tens or hundred place. They are the data are rearranged, but they are not the as per the situation. So now in a first table you have to rearrange your data according to the ones place values. Now in a first when once you completed the ones place data, you sorted your data at the position of ones place. Now go for the second table. Now you apply here, you focus on the tens place data. Don't go for the ones place or the hundred place. You have to focus on the tens place data. Now again rearrange your data as per the tens place data order. So again you rearrange your data in a sorting format, like starting from 0, 3, 4, 4, 6, 8, 9. In that way you have to rearrange your data according to the tens place. Now once you completed tens tens place value you completed. Now move on the next one, that is the last one is a 100 place value. Now move on the 100 place. Now you have to focus only the 100 place data. Now again rearrange your data by the in a 100 place, and according to that one, first to fixing the value like 0, 0, 0, 1, 5, 7, 8. When you completing all three tenses, three units of data, you have to see in the last table your data will be sorted. In means the smallest value is 7. That's why the 7 are in the are holding the top position. After that 49, after that 63, after that 132, after that 543, after that 783, after that 889. So according to this concept, in our first table we have to focus only the ones digit. We rearrange the data in a ones digit units. Then we go for the second table. In a second table we take an input from the first table. Then again we rearrange the data as per the only the tens place data. We focus on the tens place data and we rearrange the data as per the sorting order. So what we will get output from the second table, it should be an input for the third table. Then we take that particular data into a third table as an input. Then again we concentrate only the 100 place, and according to 100 place we rearrange the data, and finally what we get the output, or we can say we get the sorted data from the last table, that is the third table. So this is a 3 unit digits. Suppose we having any data having a 4 digit units. So again we go for the 1000 place also. Again the digits is means ones place, tens place, 100 complete depend on the number of digits, is how many number of digits are available in particular data. Suppose we having a 5 digits number, definitely we go for the 100, ones, tens, 100, 1000, 10,000 like that. Suppose we have 6 data, so we go for the lakhs of the numbers of that one. So again completely depend on the how many Ds are available in a particular data. So according to that we have to put the tens, 100 place units values, and based on that one we rearrange our data one by one. First we go ones, 10, 10, tens, then 100, then 1000, 10,000. In that way we have to rearrange data. Finally the last output comes from the table, that is a final data. Like like this example, in the third table we get the perfect output of this all the data, and we get the data in a sorted way. So working of the Radix sort algorithm. So Radix sort algorithm works by ordering each digit for least significant to most significant. In base 10, Radix sort would sort by the digits in the ones place, then the tens place, and so on. As I told you, if the digits are come in the 10,000 place, so you have to sort out the ones, tens, 100, 1000, 10,000. That way you have to complete depend on the how many Ds are available. To sort the values in each digit place, Radix sort employs counting sort as a subordinates. This means that for a 3 digits number in base 10, counting sort will be used to sort the first, 10th and 100th places, that resulting in a completely sorted list. Here a rundown of the counting sort algorithm. So assume you have an 8 element array. First you will sort the elements by the value of the unit place. It will then sort the elements based on the value of the 10th position. This process is repeated until it reaches the last significant location. Let's start with we having a numbers like 132, 543, 783, 63, 749 and 898. It is sorted using a Radix sort. As illustrated in the figure, we can see find the array largest element, that means maximum. Consider A to be the number of digits in a maximum. A is calculated because we must traverse all these significant location of all elements. The largest number in this array is amongst of that 132, 543, 783, 63, 749 and last one is 898. So, the biggest value is that 898. It has 3 digits. So, as a result, the loop should be extended to hundreds of places. That's how we can find out. We can find out from the biggest, largest value amongst all the number from where we have to sort our data. So, 898 is the biggest value and you focus on that one. 898, the places, the maximum places 100 place. So, we can say we have to apply the loop up to the 100 place only. So, in this case we have to apply a 3 times loop. Now, go through each significant location one by one, sort the digits at each significant place with any stable sorting technique. You must use counting sort for this. Sort of the element using the unit place digits like A equal to 0. So, first we insert our data in all the array. So, put your data inside the array. Now, count the indexing like a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, now up to the 9 and you have to put the all this value. While we get the output, here to focus only the ones place, no don't go for the tens place. So, after you applying on the ones place data, what you will get? You will get first number digit is 2, then second number digit is 3, then again 3, then again 3. Here we having a 3 data item which a last value having a 3, last value is a ones place value is a 3. That's why all 3 are in the same segment. So, when we having a same data, so as per the first come first serve principle, where which data will become had come at the first time, it will go for the first come first serve executions. So, first one is 2, there is no any competition with 2, but in a 3 we having a 3 datas, but first come first serve, as per the first come first serve we take our data in that particular order. So, the second one is 3, then again 3, then again 3, then next value is 7, then 8, then 9. So, indexing will be reduces. So, 0 to 9 indexing will be reduced to 0 to 6. Now, what we get the output by the ones place or table, we get the output 132 comes under the first position, then next one is 543, then next one is 783, then next one is 63, then next one is 7, then next one is 898, then next one is 49. So, this output comes from the ones unit table, but this is not a perfect result, or this is not a right answer of the sorted data. This come only from the ones place data. So, this is output from the ones place. Now, we apply this output as an input to a second table where we focus on the tens format. Now, take data as a input in a second table. Now, here you focus on the tens place. So, when you focus on the tens place, so you first focus, don't forget about the ones place or the 100 place data, only concentrate on the 10 place data. So, as per the data, you rearrange your data like that one 0, 3, 4, 4, 6, 8 and 9. So, all are the data as per the tens format, data are come in this order. So, we take also a prefix and postfix value of the order of that particular data, like the first value, the output of the second output of the tens place unit of data, that is 007, 132, 543, 49, 63, 783, 898. this is the output of the tens place data. Again, this is not a end of our result, because here we are applying a loop only 2 times. Now go for the last loop. Now this output will be as an input for the third table as an input. Now here we focus on the last digits value, that is called a 100 place result value, and this is our last loop also. So now focus on the last digit. This means a 100 place value as per the order. First we rearrange the 100 place data like in 0, 0, 0, 1, 5, 7, 8. Now take all the prefix, postfix value and arrange your data, and the final output of this 100 place data is 007, 049, 063, 132, 543, 783, and last one is 898. Now we can't go for the next loop, because as per the logic only 100 place data and it may d equal to 3. That's why we can say we will be applying a loop only 3 times, and what we get the output after the 3 times loop, that is a final output. So this is our final output. So if you cross check here, the resulted data, all data will be in ascending order. So we can say this data is a sorted way by the using of the Radix sort principle or Radix sort technique. So the 898 is the biggest element, it is holding on the last position, and 007 is the smallest value, that's why we are holding the first position. 007 is a James Bond number holding the first position, and 898 is the biggest value holding the last position, date indexing. So this is a way to approach to sort our data using the Radix sort technique. So now we go for how we design an algorithm. So this is a concept what we discuss right now. So all are the concept. This is based on the example. Now we go for the how to create a algorithm, or we can say pseudocodes. So the Radix sort algorithm makes use the counting sort algorithm while sorting is in every phase. The detailed steps are as follows. In step number 1, check whether all the input elements have same number of digits. If not, check for number that have maximum number of digits in the list and add leading zeros to the ones that do not. So first to cross check all the numbers are in the same units places or tens places or 100 places or like in any d places. If data is not in that format, you have to put the 0 as a prefix of any value. Like that in the previous example, we put 2 zeros in the front of the 7. That's why you can put 2 zeros as per the maximum value. Now in step 2, take the least significant digit of each element. In step 3, sort these digits using counting sort logic and change the order of elements based on the output achieved. For example, if the input element are decimal numbers, the possible values each digit can take would be 0 to 9. So index the digits based on these values. In step number 4, repeat the step 2 for the next least significant digits until all the digits in the elements are sorted. And finally, the last point is the final list of element achieved after kth loop is the sorted output. So k is completely depend on the how the biggest value or the biggest the tens value, like that ones, tens, 100, which place value. The case depend on the d, how many digits are available in the particular number. So finally, we are applying a loop up to the d values. So this is an approach. Now we write a pseudocode of this algorithm. First you write as Radix sort, and you have to insert all the value inside the array. That's why you take one storage type of a structure. That type of particular structure is called a array. So maximum, first you have to send the second step, you have to find out the maximum value amongst all the values, so using the large element in the given array. So whatever the data we insert inside the array, you have to identify the biggest element of that particular array. We have a lot of algorithm to identify the biggest value, how we calculate the biggest value from the array. So this now calculate the d with the help of number of digits in the largest element or the maximum. Now create buckets of size 0 to 9 as per the order. First you fix the data either starting from 0, then 1, then 2, then 3. You start make an column also like 0, 1, 2, 3, 4. As per the unit place, tens place, 100 place, you put inside the value one by one inside the buckets like which having a holding the number will be ending with the 0. We have to insert a 0 value in the 0 bucket. When the value is ending with the 1, you have to put the value in the ones place bucket, then 2 place bucket, like that you have all the data. You fix your data in all the bucket as per the values like 0 up to the 9 in all the places. In the, either you working in the ones place, either you working in the tens place, either you working in the 100 place. So for I, starting from 0 to 2, again starting from 0, as we know that ones place starting from 0, and the D is the biggest value ending with the either with the 100 place, either 1000 place, either with the 10,000 place. It's completely depend on the number. So D we should be and at the biggest value, biggest position value. So how many times you have to apply a loop? Either when you having 100 plus, biggest value is 100 plus, you have to apply 3 times. If a value ending, the biggest values are tens place, to apply loop 2 times. Suppose you are having a value in D equal to 4, you have to apply a loop up to the 4 times. So sort the array elements using counting sort or any stable sort according to the digits at the ith place order. So by this algorithm, we can identify the performance, we can understand the performance of Radix sort algorithm. So there are two types of again performance. The first one is the time complexity, space complexity. So the time complexity of the Radix sort algorithm. So again we having a 3 cases in a time complexity. First is the worst case, best case, and the average case. So first talking about the worst case time complexity. In Radix sort, the worst case is when all elements have the same number of digits except one, which has a significantly large number of digits. If the number of digits is the largest element equals n, the run time is O of n square. So this is a worst case time complexity. Next is a best time complexity, when all elements have the same number of digits. The best case scenario occurs. If you don't put any zeros either in a free prefix, you start when you see the number, you start your operations. So basically starting from the O of A n plus B is the best case time complexity. If B equals O of n, the time complexity is O of A multiplied by n. So this is a best time complexity when we are working on the Radix sort. So average and worst case both are equivalent. So they're holding only the best complexity, either worst or average case complexity. Now last one is average case time complexity. Is basically you consider the distribution of the numbers of digits in the average case. They are p passes and each digit can have up to d different values. Because Radix sort is implemented of the input sequence, we can keep in constant, like T of n is equals to P of n plus d is the running time of Radix sort. Using the linearity of acceptation and taking into account both slides exceptions. Radix sort has an average case time complexity of O of P multiplied by n plus d. N plus d should be in the one bracket. That completely n plus d is multiplied by P and the whole thing is multiplied by the O. That is the average time complexity of Radix sort. I hope you can understand all the time complexity, best case, average case, worst case, based on that particular logic. Now we go for the space complexity of Radix sort. So because Radix sorts employs counting sort, which uses auxiliary array of size n and k, where n is the number of elements, how many numbers you have to insert in that particular memory. There's n is the number of element in the input array, and k is the largest element amongst the dth place elements like ones, tens, hundred, and so on of the input array. Hence, the Radix sort has a space complexity of n plus k. So, completely n plus k, it's a space complexity of Radix sort. So, there are two complexity, time complexity and space complexity. We understand by the formula of that one how we calculate that one, or understand the concept, or we can how we can define the complexity with the help of particular variables. So, now go for the stability of Radix sort algorithm. So, Radix sort algorithm is a stable sorting subroutines based on integer sorting algorithms. It is a sorting algorithm that does not use comparison to sort a collection of integers. It classifies keys based on individual digits with the same significant position and values. Moving forward in this tutorial, we can see some of its benefits and drawback also of this algorithm. So, for this one, we have to focus on the advantages of Radix sort algorithm. So, following of some advantages of the Radix sort algorithm, like fast when the keys are sorts, when the array elements range in small. So, in that way, Radix sort will be applied is a very smoothly way. The data elements are so bigger, and that way you applying Radix sort, it take a lot of time and calculating a lot of time. So, used in suffix array constructions algorithms such as members and the DC3 algorithms. Radix sorts is a stable sort because it maintains the relative order of elements with equal values. These are the advantages of Radix sort. Now, again we talk about the drawbacks, or we can say disadvantages of the Radix sort algorithm. There are some disadvantages of Radix sort algorithm, like the Radix sort algorithm is less flexible than other sorts because it is based on digits or letters. As a result, for each different types of data, it must be rewritten. Radix sort has a higher constant than other sorting algorithm. It takes up more space than quicksort, which is used for in-place sorting. Radix sort may be a slower than other sorting algorithms such as merge sort and quicksort if the operation are insufficient. This operation includes sub, insert, list and delete functions, as well as the process of isolating and desired digits. Because it is based on digits or letters, the Radix sort is less flexible than other sorting techniques. If the data type must be rewritten, so must the Radix sort. Now that you have explored the benefits and drawbacks of the Radix sort algorithm, look for some of its application also. So, application of Radix sort algorithm. These are applications as the Radix sort algorithm is used in a typical computer, a sequential random access machine, multiple fields key records. While creating a suffix array, use the DC3 algorithm. And the Radix sort algorithm locates location where there are members in extensive range. So, scope of the sorting technique in data structure, like sorting technique in data structure are widely used in data structure and algorithm, providing an efficient way to store the retrieved data. Different types of sorting in data structure can be implemented depending on the data size and the type of the data being sorted. Each sorting technique has advantages and disadvantages, so choosing the one that best fits the task is important. So, now talking about the application, or we can say the techniques, sorting technique with the scope also. Like in a quick sort, here we comparing the techniques and the scope. So in a quick sort, the scope is efficient sorting in data structure algorithm for large data sets. Second one is bubble sort, simple to understand and implement but unstable for large data sets. Merge sort, divide and conquer approach, efficient for larger data sets. Next one is insertion sort, works by inserting each element into its correct position, suitable for small data sets. Next is selection sort. Select the smallest or largest element from an unsorted array and places it at the beginning of the array, suitable for large data sets. Next one is heap sort. Based on the heap data structure, efficient for large data sets. Next is Radix sort. Groups elements into buckets based on their numerical values. Efficient sorting in data structure techniques for large data sets. Last one is bucket sort. Divides elements into buckets and then sorts each bucket with another sorting algorithm. Efficient sorting in data structure and the technique for large data sets. So overall, sorting algorithms are implemented for data structure and can be used to store and retrieve data efficiently. Different algorithms have different scope and suitability, so choosing the one that best fits the task is important. Data can be efficiently sorted and stored using the right storing technique in data structure. Moreover, queue data structure are also used for sorting technique in data structure. Queues are a linear data structure that follows the first in, first out principle. So challenges face sorting in data structure are sorting technique in data structure can be challenging, especially when dealing with large data sets. Several challenges can be arises when sorting in data structure. So few challenges like in a time complexity. Complexity of the sorting algorithm depends on the number of elements in the data set and how they are organized. Sorting algorithm can take a long time to complete when dealing with large data sets. Another challenge is memory complexity. In memory complexity, sorting algorithm may require a lots of memory depending on the size of data sets. Large data sets may require more memory for sorting than is available. Next challenges is computational complexity. Some sorting algorithm may be complex and difficult to understand, making them difficult to implement and debug. Next, complexity in the form of data representation. The data being sorted must be represented in a way that makes sorting efficient. Different types of data may require different sorting algorithm for efficient sorting. Another is a last one is a performance in based of that one. So depending on the size of the data set, some sorting algorithm may perform better than others. It is important to choose the appropriate sorting algorithm to ensure efficient sorting. So finally, conclusion of this today's tutorial. In conclusion, sorting in data structure is widely used in data structure and algorithm to store and retrieve data efficiently. Different types of sorting in data structure can be implemented depending on the data sets size and the type of data being stored. Each sorted technique has advantages and disadvantages, so choosing the one of the best fits that task at hands in important. So I hope you can understand all the kind of sorting technique. Today we understand the last sorting technique, that is the Radix sort, and also we understand all the concept and the application of the sorting techniques. So I hope you can understand the concept of sorting technique. So for today's tutorial, thank you.